So good morning, good afternoon, and good evening, dear authors and invited guests. It is my great pleasure to welcome you to the 6th International Congress on the Information and Communication Technology through Zoom on behalf of ICICT 2021 and the Global Knowledge Foundation, Research Foundation, sorry. As every one of us is passing through unforeseen circumstances due to COVID-19, we wish everyone and their families a safe time, and we will all hopefully get through this together. Furthermore, with immense happiness, I would like to share with you that we have received an overwhelming response this year from across 90 countries, where 1,150 papers were received and 350 papers were accepted, contributing to the success of this conference, and the papers would be published in 4 volumes this year. We are thankful to all our guest presenters on this platform to join us digitally for this conference in these unprecedented times, and we'll make this, hopefully, through the new use of technology, we can make this conference more fruitful in terms of technical knowledge, and we hope that you enjoy the next 2 days of interactive sessions. So I would like to welcome you all to technical session 1F and further introduce you to the chair of this session, Dr. Dalia Magdi. Dr. Magdi is an associate professor at the Canadian International College. She was the head of informational systems departments at the French University in Egypt and the co-director of the CRI Research Lab, and is an associate professor of management information systems.
Hello, everyone.
Magdi, yeah.
Hello, Jay.
Yes.
Hello, how are you?
I'm good, how are you?
I hope we are all safe and secure during these circumstances and the pandemic. Okay, let's start by the first paper.
Yes, please.
Sorry, guys, just a little bit of technical issue. So our first speaker is Alio Badji, and the paper title is State of the Art of the Impact of HIV and its Treatment on the Voice of PL-HIV. So welcoming you, Alio Badji, if you would like to share your screen, if you have a presentation, and commence. In the interest of time saving, I will remind you gently when 10 minutes are up, just so you can conclude and we can move forward on schedule. Thank you. Over to you, Alio Badji. I hope you guys can still see my screen.
Yes.
So the next speaker is Propan Tanzit Pong, and their paper is Enabling Cloud Computing to Facilitate Health Analytic Applications from Local Hospitals in Thailand. So I hope you're ready. If you are, please share your screen if you have a presentation. Over to you.
Maybe she is not here yet. So we can go ahead with the next presentation.
Not too worries. The next presenter will be Guanglu. If we can just check if, yes, they are here. If you,
oh, yes, I'm here.
Hello,
okay.
Perfect.
Yeah, okay.
Perfect. If you would like to share your screen at this point to start your presentation, that would be perfect.
Yes.
Thank you very much. Over to you. Guanglo is their paper title is Tough Times, Extraordinary Care, a critical assessment of chatbot-based digital mental health care solutions for older persons to fight against pandemics like COVID-19. So over to you. Thank you very much.
Yes, thank you very much. I hope that you can hear me clearly and you can also see the slides.
Yes, we can hear you perfectly and see the slides as well.
Okay, so then I start. Good day. Hello, everyone. And my name is Guanglu from Luzern University of Applied Sciences and Arts in Switzerland. I work in the Institute of Communication and Marketing. And today, I would like to present to you our research topic, chatbot-based digital mental health care solutions for older persons to fight against pandemics like COVID-19. In this talk, and we'll try to give a short overview of the state of art in the field, and also to help you understand better what our project idea is and how we will come to our product, an intelligent and humanized conversational agent driven by AI. So since the beginning of last year, our society has been challenged a lot by COVID-19, especially with the group of older people. But even without this COVID-19 pandemic, older people are facing a lot of challenges. And for example, we are facing a problem of rapid aging population. According to the WHO, the proportion of people aged 60 or more will increase to 20% worldwide by 2050. And this is a fast developing society, and usually a lot of digital communication tools come out on a rapid pace, which do not take account of older people's specific needs. In particular, we consider some public health emergencies like COVID-19, which further confine and isolate older people from our society. In this context, older people are facing a lot of issues with mental health. First of all, because of a decline of their capacities and functional ability already lead some mental issues for this kind of people. And also considering some realistic challenges, approximately 15% of older people will suffer from the mental disorders. Therefore, helping the older people to solve their mental issues to stay on a good mental well-being is an active call from WHO and governments worldwide. So why this business innovation could be profitable? What is the unique point of that? And first of all, of course, it's a strong demand for mental health services. And chatbot can understand older people's psychological needs and to make conversations, to interact with these people to understand and serve their mental needs. In this product, we plan to include some smart, inclusive health and care product architecture. That means our chatbot would be able to offer positive psychology activation instead of passive support. Our chatbot will reach out to these people to conversation with them and to understand their psychological needs. We will also introduce some simple gaming elements to help break down the technology barriers for older people. But behind this chatbot product, we will include the state-of-art technologies, and for example, AI, artificial intelligence, machine learning, natural language processing, so that our product will become a trusted companion for older peoples. In particular, we want to consider the privacy issues, which is very important nowadays in big data technology. And this chatbot will be something between different cultures and different discipline, design thinking, and technology or culture are both taken into account for the product design. And this product design will enable personalized mental health services. It will generate long-term impact beyond COVID-19. Although this field is very important to older people, currently there are not so many research on development in the field. I have listed here some representative research and development in the past 2 years. In the research field, that is the first 3 items, they are mostly discussing on the theoretical level the potential, the application potential of a chatbot in digital mental health. Some papers discuss the safety, trust, and oversight problems. And all these papers point out that chatbot could be very useful, significant to mental health. Some development, for example, a chatbot called Zemo. It's a mobile-based chatbot with cognitive behavior therapy for people who need mental support. And also there is a chatbot called Headstrong. it incorporates some active programs to counter the negative impacts of COVID-19 on youth. And this is something happens in New Zealand. And more recently, there is another one called COVID chatbot. Chatbot detects the mental stress of people caused by lockdown and quarantine during the pandemic using natural language processing. The previous application of these development show positive results. However, none of them are facing particularly towards older people. So how will our chatbot will come to life in this project phase? 5 steps, and currently we are at the market research. We understand the state of the art and also the existing products and technologies. And next step, we will do requirement analysis, means we will do quantitative and qualitative interviews and surveys towards the target group of people, collect the first-hand data regarding the psychological needs of these people. And then we'll start to design the architecture of the product. And these are 2 steps. And first is based on a rule-based chatbot architecture. If you are familiar with this field, you will know that this technology is sort of mature, and we will base our product on this technology. On top of that, we will introduce self-learning agent, which leverages most advanced natural language processing techniques. Entering the chatbot implementation phase, and we have several important points to notice. And first, this should be a very user-friendly conversational interface for older people. And in this chatbot, we want to detect the emotions of people through analyzing the dialogues, texts. And we want to provide thoughtful suggestions of mindful activities for adjusting these emotions of people, mostly based on cognitive therapy, cognitive behavior therapy. And these thoughts and feelings predictions will be personalized based on the usage of chatbot according to individual persons. And finally, we will try to validate our product and test the performance of the chatbot with user experience surveys and upgrade chatbot functions according to useful feedbacks. These are the 5 steps we plan to implement in our project. In particular, we also asked us some questions regarding different aspects of the development. And first is regarding data collection and requirement analysis. And how could we perform a thorough analysis of the requirement of people? And we planned detailed surveys and interviews in different regions in Switzerland. And initially we planned this as well in China to collect the data as a comparison group so we could understand people's psychological needs well. And this is also an important point that culture matters. People speak different languages. Usually they have different habits of using chatbot or make conversations with them. So we must understand the difference of the language or culture, the influence of this point on our chatbot design. Regarding the analytical techniques and architecture design, we will consider the state-of-the-art natural language processing techniques, but we will base these technologies also more on the more mature technologies like rule-based architectures to create a good dialogue flow. Regarding the user interface chatbot implementation, and this is mostly regarding the product design, interface design, how to make this product more user-friendly to the end user group. We say good mental well-being starts from today, and this is a short dialogue created by ourselves, not by the chatbot. But we want to emphasize here that to develop such a kind of product, we already started from an ethical point to understand how we should keep the data privacy, for example. This is one important problem, and how to obey the ethical regulations, especially in the mental health field. Some market potential and growth opportunities. And these are some numbers, mostly can be referred to this AAL Market and Investment Report in 2018. And this field is growing very fast. And in Europe, there is a lot of market potential in this field. And a lot of companies are investigating in this field and also developing product for digital solutions for older people. And most importantly, we see that there are also existing generic chatbot available on some kind of platforms such as Apple Store or Google Play, and online marketplaces, Apple stores, and offer accessible routes to market. That means if we have such kind of product developed, we can easily use these channels to broadcast it to end users.
Sorry to interrupt, but if you could aim to conclude within the next 1 to 2 minutes, that would be perfect.
Yeah. Actually, this is the last slide, and this is our project team, project initiator in Switzerland, and we are working in the communication science field, but myself is with a technology background. Currently, we are in collaboration with companies in Switzerland and in Europe, and to apply fundings for such kind of projects and to bring our ideas into the final product. Thank you very much.
Perfect. Thank you very much. Dr. Magdi, if you had any questions?
No. If any other one has any question, no, for me, it's okay.
Perfect. If anyone else in the audience had any questions, if you could pop it into the chat. If not, we can move on.
Hello.
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 Yeah, but I have one question. I belongs to virtual this meeting room B, but it is saying that host has another meeting in progress. How to resolve this?
Yeah.
Any idea?
This is, if you'd like to go. So this is actually meeting room 1F. So there is a different link for meeting room.
Virtual
Did you
room
say
B.
you're looking for B?
Yeah.
Perfect.
Yeah,
What
I
can
think
do is-
similar thing is happening for other virtual rooms as well.
Yeah,
I
yeah,
just
yeah.
checked.
This is the link for meeting room B. If you would like to use that, if you are meant to be in meeting room B, this is F. So that is that, and I will also post the meeting ID and passcode for you.
Yeah.
Can I interrupt? Hello, everyone. I think there is a technical problem from the ICICT because I just emailed them. I'm supposed to present my work as well, 12:15 in virtual room D, and then the line just cut off. So I think it seems like they have a technical issue. So just to let the others, because I'm in the same boat with you guys as well. They will let us know maybe by email.
Okay,
Yeah.
you mean we have to wait for some minute. They will resolve the issue. Is it the case?
Yeah, that's what I've been told.
Yeah.
They will email us, yes.
Yeah. Thank you. Thank you.
You're welcome.
Perfect. Thank you. What we shall do is our next presenter is here, so hopefully they are also ready to present.
I have a quick question. I don't know if I dropped in a little bit later than usual, or my time clock is a little bit different. My name is Prao Pan, and I'm supposed to present.
Hiya,
12:30.
Prabhan. Yeah, we actually did have 2 individuals before. Unfortunately, you weren't here, but that is fine. What we should do is we'll move on and we'll get you in to this session just after the individuals have finished. So we'll just
Okay,
do is
so,
bring,
after
but
this,
you will have an opportunity to present.
Oh, thank you so much.
Perfect. Thank you very much, Prabhan. So our next speaker is Jianyun Liu. I do apologize if I am pronouncing any names incorrectly. Wholeheartedly, I do apologize. But the paper title is An Image Strategy Based on Saliency Detection Using Luminance Contrast for Artificial Vision with Retinal Prosthetics. So if you would like to present now and take over and share your screen, that would be perfect. Thank you. Not to worry, what we can do is move on and hopefully individuals can sort out any technical issues they are having at the end. Katerina Lingenbolch, are you here? If you are, if you could unmute yourself just to ensure before we move on.
Katrina, if you're here, please check me so I can unmuting you. I think she's not.
Not to worry. This is Shah Siddiqui from University of Portsmouth. Are you here, sir?
Is there anyone on behalf of Mr. Shah? Because Mr. Shah is not here. No.
Nope, not to worry. Soo-Yun Choi from
Yes.
Hong Kong University, South Korea.
Yes. Yes. I'm unmuting you, so you can go ahead with your presentation.
Yeah, hello.
Hello.
Can I start now? Right now?
Yes, you can stop. Perfect.
Yeah. Hello, we are Team Trailer at Hongik University in Korea. We conducted team project under the theme of assistant device aimed at improving the treatment effectiveness through the formation of proper inhaler usage habits in patients with early asthma. So our team name Trailer, which combines trace and inhaler, contains a solution to the problem of following their breath in the inhaler usage process of asthma patients and forming proper usage habits. I want to begin by an instruction design that effectively corrects the usage habit of asthma patients, and I will move on to demonstration of the development process of a new product category called Asthma Inhaler Assistant Device. To get started, let's look at some key metrics of asthma. First of all, asthma is a chronic respiratory disease that causes repeated and paroxysmal symptoms such as wheezing and attacks of breathlessness. Around the world, 339 million people are suffering from asthma, and the prevalence is increasing. The use of asthma inhaler is the most recommended method for the treatment of asthma. However, since asthma inhalers rely on the patient's inhalation techniques for the effective drug delivery, it is very important for the patient to use it properly. If the inhaler is not used correctly, the dosage reaching to the lung is about 1/3 as compared to when the inhaler is used correctly. Surprisingly, 84% of asthmatic patients are using inhaler correctly, and medical staffs are in difficult situation to help it. In order to help asthma patients, we propose a new product category called Asthma Inhaler Assistant Device that monitors patients' usage behavior and conveys real-time feedback. We built a working prototype that provides information to the user according to the order of inhaler use in 3 steps. Keep the inhaler horizontally, inhale deeply enough, and hold the breath for 10 seconds. In order to recognize users' mistakes simultaneously during the usage, which happens in such a short time, the best way might be to provide immediate feedback on the inhaler itself. Our problem was defined as how might we guide users to correct behavior while they are using the inhaler. We then considered all human senses to choose best way for users to know how they do with the inhaler, most importantly, without abstracting the inhalation process. As a result, visual sense was selected as a main channel. In addition, auditory sense was further considered to motivate users to hold their breath long enough. We conducted a benchmarking study on existing visual interfaces of the latest digital devices. As you can see in the pictures, they convey their status to users using small LEDs in real time. Even though they display only a small number of colors in a restricted area, it's quite effective to interact with users. Though pattern and color small LED light modules can deliver information intuitively and explicitly to users. As I mentioned before, the device provides immediate feedback for 3 interactive steps. So we decided to apply 3 LED light modules to our asthma inhaler assistant device for real-time feedback. For forming familiar mental model of users, the LED colors of feedback take metaphor of traffic lights. Also, the device color feedback system keeps users informed about what's going on through appropriate feedback within reasonable time. Our inhaler assistant device needs to help users in holding their breath for 10 seconds. Therefore, we tried to design not only informative, but also motivative and enjoyable 10-second sound. Accordingly, we designed 8 simple sounds and use alert and almost end alert. Then we set up 3 evaluation criteria: bored, tensed, and distracted, to understanding the impact of these 3 factors on how users feel motivated and enjoyable. The results showed that only the boring feeling varied depending on sounds, not the tension nor the distraction. A 3-way ANUVA gave 2 graphs for the boring feeling on the right, which clearly shows that people felt less bored when there were unit alerts. Similarly, a 2-way ANUVA on feeling tense showed that when there was an end alert, people felt more tension. Accordingly, motivational and attentive sound was designed to avoid feeling bored. A beep alert is given every second for 1 to 6 seconds, followed by a beep beep note from 7 to 9 seconds to form tension and not to feel distracted. Finally, long beep note assures that users reach the end of 10 seconds breath holding. Then, to validate the asthma inhaler assistant device concept, we recruited those who are actual asthma patients or suffer from similar disease and let them try our working prototype. Subsequently, we measured their performances at 3 steps, and each time both quantitatively and qualitatively. Firstly, does the inhaler assistant device help users to hold the inhaler horizontally? The data was shown dramatic improvement in performance. Overall, the proportional time they kept the balanced posture is more than 19 times when they used the inhaler with the prototype than when they used the inhaler alone. Secondly, does the inhaler assistant device help users to inhale deeply enough? The figure shows the data of 3 subjects because the other 2 not actually want to inhale due to the caution of COVID-19. They all performed better judging from the peak inspiratory flow rate, which is a crucial element for treatment effectiveness when they used the inhaler with the prototype. Finally, those inhaler assistant device help users holding the breath for more than 10 seconds. 3 out of 4 reached the goal. Subject 2 did not reach the goal but improved after the second trial. Thanks to the design sound, subjects were naturally counting each second in their minds. Overall, they said the sound gave a cheerful feeling. Subjects remember this experience as both informative and motivational. However, real-time feedback using LED indicators sometimes engendered misunderstanding of the meaning or misreading of the behavior. Since horizontal holding posture is important for guaranteeing about a dosage of inhalation, the color of first LED changes instantly during inhalation. Users who lacked understanding of these were embarrassed during inhalation. Therefore, we plan to add icons on the device to improve the understanding of the interaction. In addition, existing design issues also need to be improved by future study. Users are inclined to perceive red and yellow color as failure of step, which later motivates users to try again. Thus, when subjects show the second LED in red or yellow, they tended to repeat inhalation rather than hold their breath. Instead of just changing the current color composition of LED, future studies should investigate how to create an interaction environment where users don't make the mistake. Thank you for your listening. If there are any questions, I'll do my best to answer them. Thank you.
Perfect. Thank you very much. Dr. Magdi, if you had any questions.
No, thank you. Thank you for the interesting presentation. Thank you.
Not to worry.
Thank you.
What we will do now is move on to our next presenter. And I believe next presenter is Paulina Fubain. If you are here, if you could unmute yourself.
I think we will go ahead with the Pachi.
Oh, not to worry. Is Alio Padji, are you here?
Yes, he's here. But I would like to. Where is the micro?
Well, the title of this paper is The State of Art of Impact of HIV and its Treatment on the Voice of PL-HIV. So whenever you're ready, if you would like to share your screen and carry on with your presentation. Thank you.
Okay, hello. I would like just to say that the presenter is deaf. So then if you would like to ask questions, use the chat in order to talk to him. Okay?
Sure. If you have any questions.
Yeah. I say that the presenter is deaf and he has problems of voice. So then he's going to be, I'm here just to help. Okay?
That is absolutely fine. Perfect. Thank you very much, sir.
Okay. Don't start. That's it.
That FGR impact of HIV and its treatment on the voice of person living with HIV. This work we carried out together with teachers at Atlantic University. This include Dr. Yusuji, Dr. Ibrahim Majo, Dr. Pepe Aditite, and Dr. Bubekir. For the presentation, we will follow the following plan. We start with the introduction. We will discuss about the context and the problematic of this work. Before recording the variation of voice in automatic speaker recognition, then we will discuss the influence of HIV and drug on patients living with HIV. Finally, we will have a brief discussion ending with conclusion and perspective. Introduction, context and problematic. In the context of monitoring patient living with HIV, in cross-border area between the Gambia, Guinea-Bissau, and Senegal, the confusion between patients through the lost to follow up and patients lost to follow up has led researchers to stress the importance of establishing a unique patient identification system. For this voice biometry or automatic speaker recognition was chosen as a technology because of its advantage over other types of biometry, such as the cost of identification, or the cost of implementation, and remote identification. For the problematic, given that the voice was retained as a factor in identifying patients and that it very according to age, gender, email, state of care, etc. We asked ourselves in this work on the influence of HIV and its treatment on the voice of patients living with HIV. Remainder of voice variability in automatic speaker recognition. In automatic speaker recognition, there are three sources of voice variability. Variability linked to technology such as acquisition device like microphone integrated to phone, and also in transmission channel like cable, optical fiber, waveguide, environment like acoustic room, market or airport. The variable linked to the conversation did include an interlocutor because we speak different depending on who we are talking to. The context because we speak different in public on the phone or in a meeting, etc. The place because we speak in a low voice or a loud respectively in a quieter or noisy place. The language because we are much more comfortable speaking our mother tongue. The variability linked to speaker did include inter-speaker variability, which is due to the difference of the anatomy of the speech organ, such as the larynx and vocal tract. The intra-speaker variability, which is due to a set of speaker-dependent parameters, like gender, state of health, etc. A particular case, intra-speaker variability due to an infection or pathology of the phonatory organ. It can be caused by overuse of vocal cord mucosal lesion, effect of toxicant on the vocal cord, effect of drug on the vocal cord, neurological disorder, etc., and can be manifested by dysphonia, pain, heart failure, reflect voice, decreased tone, etc. Influence of HIV and drug on patients living with HIV. Neurological disorder and voice disorder. Neurological disorder are disease of the central or peripheral nervous system that affects the brain, spinal cord, etc., and are generally responsible for communication disorder, such as dyslexia and aphasia, but also vocal disorder, as many studies have shown. Why talk about neurological disorder and voice disorder? Because central nervous system damage from HIV is common and can occur at any stage of infection. This leads to neurological disorder and consequently vocal disorder. HIV and voice disorder in patients living with HIV. 3CG conducted by Matthew and G. Bat and involving HIV positive patients have shown. For the first stage, 80 patients with enrolled and experience consists of subjective and objective analysis of certain vocal parameters. The research shown that the voice parameter of almost all patients were affected even in the absence of directive pathology to the phonatory mechanism. For the second stage, the same patient will enroll and experience consists of test performance to assess aphasia, dysphagia, joint frequency of speech and voice disturbance. The research show oral motor function problem, voice disorder and dysphagia. For the third stage, 15 patients were enrolled and experience involved to analysis of language and learning parameters. The research shows significant impairment of language and learning parameters. From the result of the three stages, we can show that active itself can have influence on the voice of patients living with HIV. Opportunistic disease linked to HIV and voice disorder. Voice disorder can also be due to opportunistic infection linked to HIV. For example, many cases of dysphonia or heart illness related to disease have been reported in the literature. Among them, opportunistic disease, we can see Kaposi sarcoma, cytomegaloid infection of the laryngeal nerve, disseminated histoplasmosis, penicillium magnifique infection, pneumocystis jirovecitory infection, laryngeal cryptococci, chronic herpes simple laryngitis, emphasis herpesiology, laryngeal leishmaniasis, etc. Drug and voice disorder in patient living with HIV. A certain drug induce damage to the vocal cord by various mechanisms, such as deposition of substance on the mucous membrane, formation of edema, necrosis, paralysis of vocal cords, etc. In our case, the include medicine combined with ART to treat certain opportunistic disease or infection. Among them, we can see some inherited corticosteroid like diclomethasone, budesonide, ficatosine, etc. Some antithrombotic and anticoagulant like heparin and warfarin. Some antihypertensive drugs like atenolol, propranolol, etc. Some neuroleptic drugs like clozapine, risperidone, olanzapine, etc. Discussion. It is possible to identify persons living with HIV by their voice. We say yes, because on voice variability is inherent in speaker recognition technology, and there are solutions to it, like updating model and do identification. For updating model, different options are possible, such as deleting all older models and creating new ones with new and old training data. Readjust all models with new training data. Re-estimate all models with the new training data only. For identification, it consists of double identification of user using two-factor voice and another factor like password or PIN. Which solution is suitable for the identification of person living with HIV? The solution is to update the patient model by deleting them or increasing new onto by combining the older learning data with the new learning data. This will result in a voice of the same patient at different time and circumstance, and therefore allow the system to learn the variation of the voice of patient. Conclusion and perspective. HIV infection can affect the voice of HIV positive patient by causing damage to their central and peripheral nervous system. Similarly, the associated opportunity disease and their can also affect the voice of patient. Despite this, it is too possible to identify them with HIV using their voice in order to deal with recognition problems that may arise from vocal disorder. Upon incubation, since the HIV infection can cause voice and communication disturbance in HIV positive patients, you wonder if it is not possible to use voice and speech parameter to change its HIV. Thank you for your attention.
Okay, thank you. He has finished his presentation. And then
Thank you
if you
very
have
much.
question, for example, to ask, use the chat because he is deaf.
Thank you very much for your help as well and your assistance. Dr. Magdi, if you did have any questions, feel free to type them into the chat box real quick. Otherwise, if you were to say no, we can move on.
Sure. Thank you. No.
Great. Thank you very much for the talk and for your assistance as well, sir. We'll move on now to our next presenter.
Hi.
So if everyone can see my screen, introducing Ms. Propan Tanzit-Pong and her paper, which is Enabling Cloud Computing to Facilitate Health Analytics Application from Local Hospitals in Thailand. Over to you.
Thank you so much. So today we were looking at another big question in health operations and also with the current situation of COVID-19. So first of all, in health operations, we normally discuss difficulties on the design process for the service. First of all, health providers are treating patients with multiple symptoms and cases, so there are many inputs. To prepare for a service, many routings, which means many wards, many treatments, many prescriptions, many departments represented by the node in the middle are prepared to treat specific patients. So there are with the various and variety of ways and treatment methods. And at the end, even though we have treated patients out, each and every one is different. So we have different outputs. So in terms of the process itself, this is a complex process. Thanks to nowadays that we have, we are able to track medical records in the healthcare process using electronic medical records that could contain a structure of data in a structured form. And the database provides us opportunity to explore decisions and patterns in the relationship inside the data. So we are focusing on medical records which contain prescriptions data in terms of dosage and brand, manufacturer, diagnosis, and good thing that everything is recorded under the structure of ICD-10. We have reimbursement plans and level admission dates, cost, prescriptions. The major challenge here is that even though we are able to understand the data, but collecting the data from local hospitals in Thailand, it's very hard. So we have to contact all the IT department and they collect the data differently. So the hard part of the project is to be able to communicate with all hospitals in order for them to share the data under our grant. And we learned that the data, we have a lot amount of data is very, very big. And also we have learned that there, even though we're dealing a lot with doctors and physicians, they don't have enough knowledge in handling the data when it comes to big data. So the data is collected from the regional part of Thailand. These electronic records was transferred by asking them to connect us with a scripted IP using university connection. At the end, we are able to collect the data consolidated into a structural SQL language. And in terms of cleaning the data, we are able to collect identification of the patients, the patient records, the treatments, test results, and other health information. We do have to clean the data, which I'm going to talk in next slide. After cleaning the data, we compare the consistency of data output by using different platforms. The SQL-based platforms such as Cloudera and Hardened Sandbox, and independent NoSQL database of MongoDB and CouchDB. The results from testing and evaluation contributed different speed of execution time and stability of the service, but at the end we could confirm that all of the outputs are creating the same set of data. We later on load that into Amazon web service, which eventually we also encrypted for the usage under university connection. This is part of the relational diagram by mapping the primary key, foreign key from different platforms that hospitals are using. And also it takes time to understand their own primary key and foreign key in order to link all the small tables into a big table that we are analyzing at the end. And there are also problems with translating. There are some scripts in Thai, there are missing values, and there's a lot of separation in terms of numbers and the units. For example, the dosage in numbers and also separations of its unit that we have to also understand the nature of the data itself. Our model estimates violation prediction in order to understand how well the data extraction and the outcome of data loading is. We suggested a regression model, the model to test what could we learn from that big data. So the model estimate violation of prediction from cost of treatment and total dispenses from multiple health benefit plans in Thailand by focusing on the three main chronic disease. They are diabetes, cancer, and hypertension. And this is how I map the association of the programs and the disease characteristics and determined by the tendency of prescription. And there are guidelines that government provide for Thai for the hospitals in Thailand. These guidelines suggest what type of prescription that you should prescribe to patients. So I try to understand the mapping of the prescription guideline with it's a Y, a following a guideline, a N, and not follow the guideline, or did nothing. So I turn it into a 1, 0, and -1, and test it through regression model. So regression model suggests that that we have significant positive coefficient of number of cancer and hypertension patients with the violation of prescription consistent with the guideline, specifically for the Universal Health Coverage Program. So this is a program for everyone. If you are holding Thai national ID, you get to get the health benefits from any hospitals. The result also suggested a significant positive impact of number of patients with violation for hypertension treatments. So these results, we could observe an overridden guideline that aligns with availability of physicians to co-endorse the drug or prescription outside the list provided by the government for treatment. And so in conclusion, we are able to learn that at least we could handle the data and learn that EMI is useful to investigate complex service. Regression suggests that physicians are more likely to ignore guideline if the patients are holding universal coverage scheme, and they are less likely to violate the guideline if the patients are from the government office. And the evidence here suggests us that with the availability of physicians to prescribe the use of prescription or medication, they intend to do that if they are for a very severe treatments, such as for cancer over hypertension. So the implication of this study should be able to suggest, first of all, for the patients, for the right to get health benefits if they want to, what are the right benefits they are holding. The policymakers in terms of interface between economic model and social health benefit plans, and for the service providers, for the hospitals, to be able to plan a better care for everyone. And this is a very simple infrastructure that we could learn from a small country like Thailand that could be able to suggest more when it comes to overcome a global pandemic such as COVID-19. And that would be all for my presentation today. And if you have, I have not a meeting right now. So if you could email me at prabhan10.10@nida.ac.th, and I would have to leave the room now. I'm so sorry for that.
Not to worry. Thank you very much for your presentation.
Thank you. You all have a good day.
Have a good day. Bye-bye. Not to worry. As we'll move on to our next presenter, Jia Yung Liu. If they are not here, we can move on. Again, that's fine. We'll move on to, is Katarina Lingelbolch here this time? Hello? Hello?
Yes, I'm here.
Hiya, I can see you now, not to worry. If you would like to, so I'll just introduce you first, sorry. Katarina Lingelbolch is from the University of Stuttgart, Germany, and the paper title is Identifying the Effect.
Mr. Jay, sorry for the interruption, but Jian will present the presentation.
Sorry about that, Katarina. We'll come back to you straight afterwards.
Yes,
I apologize.
yes, Katrina, sorry about that.
Not to worry. If you would like to take over and present your PowerPoint, you can share your screen now. Feel free to. Thank you.
Hello, everyone. My name is Liu Jianyun. My research work focuses on artificial vision, mainly focusing on science-based imagery processing algorithms under artificial vision. Today it's divided into 4 parts to share with you. First, let's look at the research background. Blindness is one of the most serious disabilities. Visual impairment has become a serious public health problem in China and even in the world. Among the major diseases that cause visual impairment or blindness, retinal degenerative diseases such as retinitis pigmentosa and age-related macular degeneration have not been effectively cured clinically. For these 2 kinds of diseases, foreign researchers first put forward the concept of visual processes. Retinal processes has been the most viable way to the visual function recovery for some retinal blindness like common AMD and RP. It is an implantable micro devices encapsulating some electrical electrodes along with one micro camera and vision processing module as external part to collect and convert image into the corresponding electrical stimulation mode. However, affected by the limited number of implantable electrodes, the restricted location of electrode away implantation and the complex stimulation conditions in view at present stage and for a long period of time, the artificial vision provided by retinal processes is a kind of visual perception composed of discrete facets characterized in terms of much lower resolution, limited visual field, large distance between fast-fin spots, small dynamic range of expressible brightness, irregular induction of color information, and lack of depth information simultaneously. In order to meet the daily visual task requirements of the implant wear, such as obstacle avoidance, navigation, object recognition, and so on, and further improve the functionality of the retinal prosthetic device, it has been an important impact of losing prosthetic vision research that studying and implementing certain image processing strategies for the vision processing unit to extract the enhance the most salient information from the captured natural scene. Furthermore, to optimize the visual perception that the implant subjects can perceive. So we propose to improve the global luminance contrast image saliency algorithm. In the paper, RGB and YOV color system were selected to present different image information respectively. The color image was then graded and computed to generate 3 saliency maps by luminance contrast commutation. After the equalization, an adaptive enhancing strategy called visual attention simulation processing was proposed for further refining the silent map under different ways. They were integrated to obtain the final silent map. At last, pixelization was carried out for simulating the perception of artificial vision. The specific image processing stage is shown in the figure. The main processing is divided into 3 parts: color space transformation, global silence, and visual attention simulation processing. The main idea of ILC is the silence of each pair is the sum of the Euclidean distance from all other pairs in the image, generating silence map. Visual attention simulation processing is our main job. The specific visual attention simulation processing is shown in the figure. Visual attention simulation processing was proposed to adaptively extract the most attended realm. First, equals the image was proposed to get the gradient of the image. Then attended point detection and ring expand were applied to get the most attended ring. Based on these results, an adaptable constrained weighted item could be obtained. Finally, a YOV silence map was processed by weighting the equal image. Next comes the evaluation experiment based on improved algorithm. This paper chose 2 benchmarks of MSRA and ICICT to validate our post-silence detection algorithm. Considering the character of real time, we test the strategy proposed by the paper in ICICT database to get the average time per image with cropped as resolution of 173. Table recorded the average time required for each step. From table, it can be seen that the visual attention simulation processing stage takes the most time. The total time spent proved that the strategy proposed by the paper could achieve real-time processing in the particular application. Silence maps from different silence detection methods. From the figure, it is seen that ours is closer to the ground truth than others. In order to verify the strategy proposed in the paper, qualitatively, PRF measure and LC were chosen as the evaluation measures. Our proposed strategy was superior to other silence detection algorithm. For ICICT dataset, when the PR curve has a recall rate of less than 1.6 and the improved algorithm proposed in this study brightens the whole image, where background points are misjudged as foreground points. However, the overall silent points of SR and SM algorithms are missing. From MSRA, the ephemeral result of our strategy was higher and flatter than others above the threshold 6.4. From ICICT, our results were higher under most segmentation threshold. This data highlights significant objects on the whole, so the larger the threshold is, the better the effect will be compared with other algorithms. Well, from the ICICT testing results, our strategy was slightly worse than the SR, and in any threshold, outperformed the SM and LC. The last part is vision simulation experiment of processes based on improved algorithms. The picture shows our experimental platform and environment. The experiment was carried out in a quiet and dark professional laboratory to reduce the interference of external light and noise. In this study, 24 subjects from Shanghai Ocean University aged between 80 and 88 were recruited. This paper stimulated the artificial vision of the retinal processes implanters. According to the epidemiological data, a dataset including 70 objects for blind people was adopted to test the accuracy. Results in figure indicated our strategy could obtain the silent object more precise and made the foreground more conspicuous, which outperformed the DP and the orange LC. This paper evaluated different image processing algorithms from recognition accuracy, recognition response time, and recognition coefficient. Even the images processing algorithms were evaluated from recognition accuracy, recognition time, and identification index as shown in the figure. It could be seen that the proposed algorithm was more accurate than others. Moreover, the recognition accuracy of LC was lower than that of DP. Compared with the results of LC and in DP, our aroma has the shortest reaction time. Finally, I make a summary of my research work. Due to the limited number of electrodes, retinal prosthesis only provides low resolution visual perception, which requires image processing strategy to optimize visual information, helping the implant complete tasks such as object recognition and navigation in daily. In order to optimize the visual information, the paper presents a method to calculate the image silence based on LC, compare the image color space conversion with dog of bionic attention mechanism. This is the end of my report. Thank you.
Thank you very much, Dr. Magdi. If you had any questions?
No, thank you.
Not to worry. Thank you very much. And what we'll do now is move on. So sorry about previously, Katarina. So this is next speaking is Katarina Lingenbolch from the University of Stuttgart in Germany. And the paper title is Identifying the Effects of COVID-19 on Psychological Well-Being Through Unsupervised Clustering of Mixed Data. So over to you, Katarina.
Okay, can you hear me? Is it
Yes.
clear? Okay, perfect. And you can see the screen? Just
yes, also
to know where we are. Okay, hello everyone. Thank you for the opportunity to present our research on this conference. My name is Katharina Lingelbach and I'm currently working at the Fraunhofer Institute and the University for Industrial Engineering. And today I want to present you our approach to identify the effects of COVID-19 on psychological well-being through unsupervised clustering for mixed data. And the motivation and research question is, so we have an inevitably impact of the COVID-19 pandemic and the associated public health actions such as a lockdown on psychological well-being and the quality of life. And there are differences in the protective resources and effective coping among individuals. And such differences can be due to pre-existing psychological disorders and psychological personality traits, high concerns of persons at higher risk of a severe course of disease, for instance, due to a cancer disease or other lung diseases, or occupation particularly burdened by the pandemic, for instance, physicians or in the health sector. And the importance lies in identifying especially vulnerable population subgroups and their characteristics in order to implement targeted preventive interventions, which also promote mental health without a major delay. And for this, machine learning algorithms have a specific potential to research psychological well-being during COVID-19. And some previous research already started, for instance, analyzing the posts of active members of the Chinese social network Weibo with machine learning, and they found that the negative emotions communicated in these posts and the sensitivities to social risks increase, and the emotionally positive posts and those associated with life satisfaction decreased during the COVID-19 or since the onset of COVID-19. A further research group investigated Bayesian networks and classical machine learning methods to identify persons who are vulnerable during COVID-19 in their psychological well-being. And they were able to estimate the level of mental health with an accuracy of about 80%, which is quite good. The potential of machine learning mechanisms can be especially found in unsupervised clustering methods and algorithm to identify especially vulnerable population subgroups and their key characteristics to know which feature characterize persons who are burdened by the COVID pandemic at the moment. And one challenge is that most of the time when we deal or face real-world data sets, we deal with mixed variables. That means that we have the information of age, which would be a numerical variable, but we also have the information of sex, which is a categorical variable. And most of the times when you ask participants or persons to evaluate their current feeling, it's on a scale, and most of the scales are ordinal, so cannot be interpreted as numerical. And how can we combine numerical, ordinal, and categorical variables in a distance measure for the clustering? Yeah, so this was our, this was so our research question. And we used the data set, which started in April, beginning of April until August 2020. We had the data from 173 participants, but they also answered the questions multiple times. So we had a longitudinal information from them, and the questions were health-related, social, behavioral, psychological, and their demographics. And the question was, what are the effects of the COVID-19 pandemic? So what we did, we used unsupervised clustering approach, and to determine which how many clusters we are assuming to find in the data set. We used the elbow and the silhouette method. We also compared them to see if they come to similar results. And for the clustering, we use a partitioning around medias, a PAM algorithm, which is called K-mediu-eats, with the grower distance suitable for mixed data types as a similarity measure or distance measure. And in the next step, we identified the key features which explained the cluster affiliation in a classical machine learning approach. On the table, you can see, for instance, the relevant questions concerning mental well-being and psychological health. So we had some occupational concerns, financial concerns, infection concerns, and some established scales from the psychology domain. So what is the PAM algorithm and the K-mediu-eat with the grower distance? So the grower distance is a similarity measure from the 70s, and it is very suitable because it uses several, two different distance measures, which is the range normalized Manhattan distance for numerical and ordinal data, and the dice coefficient for estimating the distance between nominal data, so categorical data, which would be, for instance, sex. And in the matrix of the grower distance, these scores are combined. And this allows to judge how similar one element, which would be one person, is to another element, which would be another person, and to check whether they belong to the same cluster or to different clusters. And the K-mediu-eat clustering is suitable because it uses the mediu-eat of a cluster as a central eat, so as the central point. The mediu-eat would be then the centrally located object, and you calculate the distance by taking the objects of the smallest sum of relative distances to all other objects as initial mediu-eats, and then assigning each object to the nearest mediu-eats, which would be then the initial clusters. And so the clusters moves by each assignment in that direction. What is critical is to decide how many clusters do I have in my data. And you have got two possibilities, or even more, but these are two really common possibilities to judge how many clusters are in the data set. And one is the elbow method, where you estimate or where you calculate the sum of square errors of the distance between the sample points in each cluster. And you do it for the different cluster numbers. So the K is the you increase the cluster numbers and just check at which point we have got a significant drop in the line in the graph. And this is a visual inspection method. So you see there's this drop which resembles an elbow, and this would be the optimal number of cluster. And the silhouette method is uses a coefficient which ranges between -1 to 1, and high values indicate that the element has a high similarity to its own cluster and a low similarity to the adjacent neighboring cluster, which is the optimal case. And in our case, we had for both methods the optimal number of three clusters in the data. And you can see this by the average silhouette score of 0.26 compared to the silhouette score for 2 and for 3, which were lower. So then we did the clustering, and what was interesting now in the next step is how do our clusters differ in the responses and the variables. And we checked this by using bootstrapping, which is a method for statistical comparison. And yeah, the data was 2,000 times bootstrapped, and we looked at the confidence intervals, the 95% confidence intervals. And the clusters differed significantly in mental well-being, psychological distress, financial concern, and occupational concern, which would be a manipulation check, more or less, because they should differ in these, because we clustered on these. But what was really interesting was they also differed in age. So younger persons reported greater financial and occupational concerns, increased anxiety, higher psychological distress, and reduced subjective well-being. They were assigned to the cluster which can be described as the concern cluster, and the cluster which has the highest burden during the pandemic and the highest impact on their psychological well-being, negative impact. So in the next step, we were interested in predicting the cluster affiliations and the identifying key features. So which features were particularly informative for the clustering. And we compared 4 machine learning algorithms for this purpose, had a classical machine learning pipeline. And to identify the key features, we used feature wrapping via sequential feature selection and the feature importance embedded in the random forest. And our our models performed quite well. We could predict the cluster affiliation with a high accuracy. So you can see it for the train and the test, and we are for the random forest. We are really high with 0.944 in the imbalance accuracy score. And the key features were occupational and financial concern, psychological distress, current well-being, and interestingly also age. So the information of age, which age a person has, was significantly informative for the clustering, which is an interesting insight. So for the conclusion, our unsupervised clustering approach could identify individuals with reduced psychological protective factors and increased psychological distress. And the key features determining mental health during COVID-19 are financial and occupational concern, psychological distress, current well-being, and age. So younger persons reported greater burdens and lower psychological well-being, which is an important finding to also think of tailored actions and preventive actions to avoid psychological disorders during COVID and during crisis like COVID. And yeah, these insights are important to provide such cluster tailored recommendations, and this could be done via a web application, which is our next project, our next research project to implement these algorithms for an online web application. And yeah, this should help to alleviate concerns decrease perceived distress, and improve the psychological well-being as well as quality of life during crisis. And in general, it could also be applied. Yeah, many thanks for your attention. And yeah, we have some further publications. In case you're interested, you can go to my ResearchGate account and ask for them. And yeah, thanks for the rest of the week team, which was my research team.
Thank you very much, Katarina. Thank you for your time. Dr. Magdi, if you have any questions.
No, thank you. Thank you for the nice presentation. Thank you.
Thank you very much. Enjoy the rest of your day. We will move on now, guys. I hope you can see my screen. Our next presenter is Shah Siddiqui from the University of Portsmouth here in the United Kingdom. And the paper title is A Next Generation Telemedicine and Health Advice System. So Mr. Siddiqui, if you're here, if you'd like to unmute yourself and start to share your screen and present.
Yes, just give me a second. I just.
Not to worry.
Can you see my screen?
Sorry, yes, I can see your screen, yeah.
Thank you to the organizer for giving us the opportunity to present our paper here. For this research, I have from the University of Portsmouth, Adrian Hapgood, Alice Good, Ellen Gio, and I am Shah Siddiqui. And from our partner organization is Time Research and Innovation. We have Wahidur Rahman, Ilyas Hussain, Murshidullah Arifin, Rezan Firdaus, Zakir Khan. So I'm presenting today a next generation telemedicine and health advice system, and it's ANCHOS. So as we know that clinical decision support system, a critical part of electronic health record, and can enhance health-related decision-making and being constructed upon decades. The progress of CDS is constructing through data generation, aggregation, analysis, knowledge creation, and knowledge dissemination. The recent addition of AI and machine learning have enhanced the proficiency of specialist disease and medicine. Nowadays, we can see that people can get medical advice from personal fitness app to check status of drug dose and from a separate geographical location. We are developing a portable and user-friendly web-based and app-based health monitoring system, and we have named it ANCHOS. And it can reach healthcare professional, clinicians, healthcare providers, and especially those who have socioeconomic, language, and geographical barrier, so that the system will interact with patients and doctors from all over the world, in addition with related services like ambulance, emergency, and others. We have identified several problems in UK and globally. In the UK, 1/3 of the patients, they have to wait for a week or more to get a GP appointment. And in COVID situation, it's more time they needed. NHS, National Health Service of UK, helpline, they struggle to cope with enormous pressure from the patient around the country. And most of the time, they don't provide an instant multilingual support. And the average waiting time to see a patient in any is 4 hours. Sometimes it exceeds 6 to 8 or 10 hours. And the plan is pending for Department of Health in England is approximately 124 billion for 2017 and 2018. And NHS spent at least 100 million in 5 years' time to translate for 128 languages. And also missed appointment cost, NHS 216 million a year. So moving hospital appointment to online would save millions every year. It's also very expensive in the UK to get an appointment. So you can see that it's different payment structure to see a GP or a consult with a doctor or home visits and others. What is the problem for the global population? So in 2016, the world spent $7.5 trillion on health, representing close to 10% of the global GDP. And only 20% of the world's population live in high-income countries. And these countries account for 80% of the global spending, where top 10 countries spent on $5,000 or more per person in 2016, and bottom countries spent only $30 per person. You can see the graph color-coded in lower income countries, middle income countries, upper middle and high income countries. There are other problems. 400 million people do not get health treatment and advice around the world. 100 million people are pushed into extreme poverty because of health expenses. And 800 million people spend 10% of their household budgets, for which it forced them to live only 1.90 cents or less per day for them to survive. So we have come up with a system that can include and with a patient and clinician facing application, embedding video and voice calling, multilingual translation, symptom check, as well as a health information portal, real-time messaging, location search, user database, AI disease predictions, social media, and as well as a video portal for education. We will have a data-driven approach to collect all the information from the patients, and based on the information, the doctor will assess the patient throughout the world. And we will follow several steps to collect our data, because we're going to be implementing machine learning in future developments. So there are some stages how we're going to be utilizing the data. You can see from step 1 to step 9. And what is our unique selling point? We believe that if a clinician is, they are not limited to any geographical location. So even if they live in different geographical location, they can operate 24/7. AI machine learning will detect patient language, and the call of the patient will be transferred to native clinicians who are in the UK or native geographical location, or start live translation. And in case of emergency, an alert will be sent to the patient near at NHS hospital, ambulance services with a full report and patient location. In case of non-emergency cases, the patient will be assessed with the prescriptions, and as well as we will inform the GP. Any registered NHS clinician can conduct telemedicine and telehealth consultations to a different NHS region, can join to donate time, as well as can work in flexible bank staff. And the impact. So as we see in the global pandemic, everyone is suffering. So as an international or intergovernment organization, or like WHO or UN, they can boost their capacity to reach mass population in underdeveloped rural areas, natural calamity affected areas or war zones. It will be data resources for research, finding disinformation, and resources for prevent of spreading of epidemic disease, improve quality of academic outcomes, as well as a worldwide professional network for health clinicians, and as well as professional opinion for planning and executing treatment. It will improve the existing NHS framework and reduce waiting time for GP and hospital appointments. It will eliminate less important appointments and maintain quality treatment for homebound patients, like disabled people, elderly, and mental health. Telecare system and telemedicine worldwide involved 7 million people in 2018, which was 350,000 in 2013. There are about 51,000 healthcare apps in the market, but still in the pandemic, US, European Union, and UK have recognized the importance of social tools, and they are actively supporting to develop further systems. And the telecare market in globally will be $40 billion by 2021. And there are some other market competitors already, and like Amino, PushDoctor, and Babylon, and they are also raising fund. Our potential customer will be NHS, international organization, and as well as UK and international population. We have a marketing plan as well as creating audiovisual media, and also we will have a digital campaign on social media like Facebook and Instagram. We will have several obstacles because the initial startup funding will be we see the most obstacle things, but we will try to seek alternative funding, and we also thinking of creating a committee to observe our progress, including academics from different countries. Our future plan will be have research technology. Our future target will be have 3 stages. So we have now normal stages, then we'll have stage 2, and then we'll have stage 3. So you will we will follow a loop-back system throughout our research and development, where we will build the application, then we'll modify the application, and then we'll report, and it will be continuously done. And we will also analyze and embed our system. We will take patient data, and then we will analyze the patient data, and then embed to the system, and then we will analyze the new data, and we will oversee the system like that way. Sorry, my son is banging on my door. Sorry for that. Next, as we said, we are following the data-driven approach. So we have done some of the initial work that how our data-driven approach will work. So data processing and pre-processing systems, as well as how we're going to be stage the data regarding audiovisual media, and as well as numeric data. So in conclusion, I would like to say that if we can complete this section, it will establish a world-class technology achievements of its times in health advice. It can make this world speaking and understand in any language, and it will improve the and resolve health-related sufferings. It will encourage health professionals to donate time to help disadvantaged people, user from benefits from detailed and updated international information. And as we believe that everyone in this world deserves and will receive healthcare at its highest possible standard. Thank you. If you have any questions, please feel free to ask me, and as well as if you have well, I'm sorry for banging my son. He's still banging, so I can't really go. Sorry for that. And thank you everyone for your time. And
not to worry. Thank you very much, Mr. Siddiqui. I'm sure everyone has experienced a lot of difficult situations within the pandemic and working from home, so everyone understands. Dr. Magdi, if you had any questions?
No, thank you.
Not to worry. Thank you very much, Mr. Siddiqui. So we shall move on to our next presentation. I hope you guys can see my screen. So the next presenter is Paulina Fubane from the Central University of Technology, South Africa, and the paper title is A Prediction Model for Malaria, an ensemble of machine learning and hydrological drought indices. So over to you, Ms. Fubane.
Greetings to everyone.
Sorry, could you repeat?
I will share my... Can you hear me now?
I can hear you now. Perfect. Thank you.
Oh, thank you. I will share my screen just now.
Yeah, we can see that now. So whenever you're ready.
Okay. All right. Let me just do the slideshow. I will just start just now, please. Okay, I'm just sorting out some issues here.
Are you having difficulty starting your presentation?
No, I think I'm ready now.
Perfect.
Oh, okay. Thank you very much. My name is Paulina Pawan, as mentioned. I'm going to present to you our paper titled "A Prediction Model for Malaria: An Assembly of Machine Learning and Hydrological Drought Indices." The current slide shows the presentation outline, and I will touch all the points in this given order. Firstly, the computer is a bit slow. I apologize for that. Can I please present next? Looks like I'm having technical issues that are delaying a lot.
Is there anything I can do to assist you?
I think it's sorted finally. Can I start over again, please?
That's perfect, not to worry, yeah.
Okay, thank you. I apologize for that inconvenience. Like I said, the title of the paper I'm going to present is called "A Prediction Model for Malaria: An Assembly of Machine Learning and Hydrological Drought Indices." The authors are myself and my supervisors, Professor Masinde and Professor Botai. The current slides shows the presentation outline of my presentation. I'll go through all these points in this given order. First, I will start with the background information and related literature. Infectious Infectious disease claim the lives of many people each year globally. For example, we are currently experiencing COVID-19 that has claimed many lives globally. And Africa continues to bear the burden of morbidity in regard to infectious disease in general. One of the challenges faced when dealing with infectious diseases is that most of the existing health systems that are developed to address infectious disease and other health issues face multiple challenges, such as rising burden illness, poor management strategy, intervening too late in the epidemics. To address these issues and many more, recently innovations in the realm of big climate data and machine learning have gained popularity, especially in health. And these innovations are the driving force behind several prediction tools that are developed to prevent and control the disease outbreaks. When it comes to malaria transmission, we hypothesize that drought indices could play a role. Hydrological drought indices measure, for example, intensity, severity, and duration of the drought. Hydrological indices, unlike meteorological drought indices that, for example, specify amount of rain expected or received, hydrological drought indices go further than that to specify the amount of water in the soil, rivers, or dams, which is very important when it comes to malaria transmission, because the specific amount of water in the surface can create favorable conditions for mosquitoes to breed. And in this study, we considered two hydrological drought indices, which are effective drought index, which is a measure, or so rather it compute or calculates the intensity of the drought. It also gives the available water resource index, which actually specify the amount of water in the soil. Moreover, even though there is ample evidence in the literature that links malaria incidences to climate variations, there has not been considerable reports on the relationship between malaria and water. And to our best knowledge, the correlation between available water resource index and the ability of malaria vector to thrive has not been investigated. Based on this research gap, here are our research questions in the context of Africa. The first question says, what is the correlation between hydrological drought indices and outbreaks of malaria? The second question is, what machine learning algorithms are capable of efficiently and effectively monitoring and predicting the correlation in question 1 above? And to answer these three questions, our study aimed at developing a machine learning algorithm for predicting outbreaks of malaria using drought indices and historical outbreaks of malaria. Malaria outbreaks in Limpopo province in South Africa was chosen as our case study based on the availability and reliability of data. And when it comes to our research methodology, I will start with the data sets. We had two data sets. The first one was monthly malaria instances data per district. The data was from the period of 1998 to 2019, and it was sourced from Department of Health in Limpopo province of South Africa. The second data set was monthly weather data consisting of effective drought index and available water resource index, as well as monthly rainfall. And this data set was sourced from South Africa Weather Service. Out of the data we had, the data for 20 years was used to train our model, and the data, 1 year data was used for the evaluation of the model. And this map here It shows our state area, which is Limpopo, is one of the 9 provinces in South Africa. Here I have it zoomed for better view. So Limpopo has 5 administrative districts, and the blue lines shows the boundaries between these districts. Limpopo also has 13 climate districts or weather stations labeled with numbers. For example, can be seen that Mvembe has 2 weather stations labeled 50 and 35. And when it comes to malaria instances in Limpopo, the diagram here shows that Mvembe, followed by Mupani, indicated by orange and black color respectively, have the highest malaria instance in the province, Limpopo province, especially between 2016 and 2018. Before we could build our model, our data was processed, was cleaned and pre-processed, and this phase involved feature reduction process and the correlation analysis between the variables and malaria instances. The variables, which are IDE and AEWRI, as well as rainfall, the correlation was calculated between these variables and malaria instances, and they were ranked based on that correlation. It was found that the variables with the strong correlation with malaria instances were mostly the available water resource indices variables. Once the data cleaning and preparation was done, we used the rapid miner to simulate data and build non-predictor models that I will show in the next slides. And to build these models, variables with higher correlations with malaria instances in Vembe, which was the district with the highest malaria instance, and malaria instances in, at a provincial level, were used to build the model. After running 9 models through the auto model of the rapid miner, the performance of the algorithms were compared with the aim to choose the best algorithm that could be used to build malaria prediction model. On this current slide, we have the classification performance of the 9 algorithms, machine learning algorithms, and it can be observed that all the algorithms have the same performance and very high performance. And this was based on the professional data, malaria data. On this slide, we have the same classification performance, but in this case, Vembe data was used instead, and similar observations can be done, except that now the performance is even higher. And also, first large measuring algorithm gave an error, and it was therefore excluded in further analysis. Further comparison of the algorithm performance was done, but this time based on the computation time. The algorithms performance were compared in terms of the total time, the training time, as well as the scoring time. So the rankings in these of these times were added together to find the overall ranking, whereby decision tree was found to be the best algorithm, or the one with the highest rank. And since in the previous slides, all the algorithms have the same classification performance, the decision of the best algorithm to use in the malaria prediction model was only based on the computation time performance of the algorithm. And therefore, we chose decision tree to build the malaria prediction model. In this slide here, we have the decision tree simulator, and it can be observed that the input, which is on the left side of the simulator, are the dependent variables or the predictors, malaria predictors, and based on the values input here, which can be put by moving these slides back and forth to specify the actual values of the variables. So based on the values specified, which can be put in real time, the simulator will predict or will give the prediction of the malaria occurrence. So this indicates that this simulator can be used to make prediction in a real time. It was also found that the available water resource index variables contributed the highest weight, while other variables had the weight very close to zero. This also indicates that available water resource index is the main indicator for malaria prediction, at least in Limpopo province. So after building the model, we tested our model, and the results were good because the relative error obtained during the testing was as low as 0.1%. However, this performance was not as good as it was during the training. And when you go back to our research questions, as per our first research objective, it is evident that there is a strong correlation between hydrological drought indices and malaria indices reported in Limpopo. And as per our second research objective, a decision tree malaria predictor system was built using a rapid miner. We can get to a conclusion that available water resource index is an excellent measure of conduciveness of malaria causing factor, and it is therefore a good predictor for malaria instances in Limpopo province. And the prediction capacity of the model we built in this study can be considered as an excellent decision tool for stakeholders when it comes to fighting malaria outbreaks. I will conclude the presentations by checking the future directions in that link to our studies. We recommend that further work can incorporate other variables such as temperature, humidity, and vegetable indices. And we also encourage the evaluation of the model and ascertaining the model's scalability to the other parts of South Africa, Southern Africa, and Africa at large. Thank you for your time. And if there are any questions, I'll be happy to address them.
Thank you very much. Dr. Magda, if you had any questions? No, not to worry. What I should do is...
Thank you, Pauline.
Sorry? Okay.
So I sincerely thank our authors for their...
Thank you.
Thank you. I sincerely thank our authors for their excellent presentations, contributions in this session, and for our participants for being part of this intellectual congress. I hope that this session was informative and knowledgeable as well. All the presenters will be getting their digital certificates through the mail within 2 working days. And further, all the papers have already been forwarded to Singer. The publications will be live within approximately 4 to 6 months, kindly coordinated and operated by the team at ICICT 2021. I would also like to take this opportunity to thank our chair, Dr. Dalia Magdi, for chairing this session. And this is a token of our appreciation on behalf of the team at ICICT 2021 and the Global Knowledge Research Foundation. Thank you for your valuable presence, ma'am. So just to conclude, guys, if I'll stop sharing right now. If we could all turn our cameras on, and we can take a screen snapshot of this session, just for a memory of what we've done. So if I know that we're all at home and everything, but I'm sure you all look great. So if you did want to unblock your video, and then we can proceed to take a group snapshot. Thank you very much, guys, to the people that are turning on their cameras. I'll just wait another 2 seconds. If anyone else would like to turn their camera on. Thank you to the guys who are.
Thank you, Jay. Thank you. And thank you, and many thanks to ICT. Thank you.
Thank you very much for being here, guys. I'll just take a quick photo if everyone wants to smile. Perfect. Enjoy the rest of your time. Stay safe in this global pandemic, and we hope to see you in more technical sessions. Have a good rest of the afternoon.
Thank you. Bye.
Thank you very much, presenters. Bye-bye.
Bye.
Thank you for being amazing host, Jigar.
No worries. Thank you, everyone.
Thank you, ma'am. Thank you, Dalia, ma'am.
Thank you. Thank you. And thank you for the nice presentation. Thank you.
Thank you.
Thank you. I'll get that sent over to you as soon as this is over.